back to our channel, The Classroom. Today again I'm back with the Trigonometry chapter, that is solution of right triangles, and this particular chapter is obviously of class 9. Last two videos also I have done with trigonometry. Those two are a part of this trigonometry chapter. This is the third chapter of trigonometry of present, that is syllabus, and accordingly if you have not seen the first two videos, you have missed out in any case. You can simply use that I button and check the two other videos. You'll get a clear idea about or conception about trigonometry. Now let's come to this particular chapter, which is solution of right triangles. In this particular chapter we have only examples and solved out sums. I'll just explain you before I start with the examples, nothing more to do with this particular chapter. It is, suppose an right angle triangle, you will be given the particular side and an angle, acute angle, from where you have to find out the value of the other sides or the angles. Okay, or maybe two sides will be given, you have to find the third side or the respective angles. This is what the actual chapter is about. So I have come up with a sum. You might be feeling, my god, it's so clumsy, but I'll make you understand. I hope you will not have any problem. It's very easy. Here this particular figure was given to you. Okay, this is a right angle triangle that you can understand. Now there are two triangles in it that you can consider for trigonometry. Okay, so the first right angle triangle is triangle ADC and the other right angle triangle is triangle ABC. Okay, next find the length of AC. We need to find the length of this perpendicular. AC is a perpendicular, so we need to find out the length of the perpendicular. That is not given. Given are the two acute angles, okay, for the triangle ABC and triangle ADC, and BD is given 40 meter. Okay, but here DC is also not given. Okay, so in that case the first thing that we need to do is we need to take this DC as X that I have taken. Okay, as I have taken the DC as equal to X meter, the next thing that I am going to do is calculate total BC. So BC is equal to what? BD plus DC, right? So it is coming 40 plus X, right? You can also add here, that is within bracket, meter, putting the unit. Next, in triangle ABC, that is in the bigger triangle, in triangle ABC, tan 30, okay, because we need to take the acute angle. Tan 30 is equal to, we know tan means what? Perpendicular by base. So perpendicular is AC divided by BC, AC by BC. That is equal to AC by 40 plus X, because BC we have already got, that is 40 plus X, right? So tan 30 we know is, from the previous chapter, the value of tan 30 is 1 by root 3. That is equal to AC by 40 plus X. So AC becomes what? 40 plus X by root 3. So that I have got the answer as 40 plus X by root 3. But since there is a term X which is a variable, we don't know the value of it, so we are writing AC is equal to this particular value. So now keep it in that way first. Next, let's take the smaller triangle, triangle ADC, the right angle triangle ADC. Okay, I have written there tan 45, since here the angle is 45. The acute angle is 45. So we are going to consider this particular one. Tan 45 is equal to what? AC by DC. AC by DC. Now AC we don't know, so we will keep it as it is, divided by X. Since DC we have taken as X. So tan 45 is 1. That is equal to AC by X. So AC gives you X. So let us consider, here also we have got AC. In this particular case also we have got AC. Let us consider this as equation 1, this as equation 2. Right? So the next thing that we are going to do is just equate these two. AC, both of them are equal, so just equate it. So on equating we are getting 40 plus X by root 3 is equal to X. So just cross multiply and see, 40 plus X equal to root 3X, right? So you can bring this X on the other side of the equation. So you get root 3X minus X. I have taken that together, root 3 minus 1, X equal to 40. So X you are getting as 40 by root 3 minus 1. Now you can see this is another one type of irrational number that we have got. So better, it's, you already know from the rational number chapter. If you have not seen, please check that video too. we can rationalize the denominator. So how? Just by taking the opposite sign of the denominator. So root 3 plus 1 by root 3 plus 1. We are multiplying, we are getting 40 into root 3 plus 1. Please be careful in this part, there is a lot of calculation and it's small also because of this particular one I have written that small, space was less. So 40 into root 3 plus 1 whole divided by this, you know, a minus b, a plus b, right, formula. So you are getting 3 minus 1. So at last you are getting 40 by 2 into root 3's value is 1.732 plus 1. So this comes 2.732 and 240s we are cancelling, we are getting 20. So 20 into 2.732 we are getting 54.64 meter. So this is a particular length of AC. Why? Because this is a particular value of x. Now we know that AC is also equal to x, we have got in this second equation. So therefore this is a particular value. Okay, I hope you have got it, you have understood this part. Next, we have come up with this particular figure where you have to find the value of AB. Okay, now just see that AB is having two parts, that is AE and BE. Now BC is given 30 centimeter. This particular triangle, that is right angle triangle BDA, is given, one of the acute angle is given 60 degree. That means this is the right angle. So as we have discussed earlier in the that is in the other chapters of trigonometry, that wherever this acute angle and the right angle are adjacent, that particular one is going to be taken as base and the adjacent side is going to be taken as a perpendicular. So that means in this particular triangle BDE, this DE is the base, okay, and for the triangle ADE, here also DE is the base and AE is the perpendicular, right? So let us start with the following. So firstly that I have done is, we can see that this is almost a triangle. So that means BC will be equal to ED. That's what I have written. BC is equal to ED, that is 30 centimeter. Okay. Next, let us consider the first triangle ADE. In triangle ADE, the upper triangle, tan 45 is the acute angle equal to perpendicular by base, that is AE by DE. That's what I have written. So AE by 30. Since DE is already known now, we get value of tan 45 is 1 equal to AE by 30. So AE you get as 30, you can write centimeter here. Okay, next, considering the second triangle, I can write it here in triangle BDE. In this particular triangle, we have taken tan. Usually we carry out all the sums with tan only. Okay, so it can be easier for you to calculate. Tan 60 is equal to, now I said the one with the, that is which are the angle, the acute angle and the perpendicular on the same side, that will give you the base. So that means DE is the base. So perpendicular base, which is a perpendicular here, BE. So BE by DE. BE by 30 as it is known to us. So tan 60 is root 3 is equal to BE by 30. Now 30 root 3 is equal to BE. This is a particular value that we have got for BE. So now AB is equal to AE plus BE, right? So AE and BE's value we have already got. So just put that over there, 30 plus 30 root 3 centimeter, that is equal to 31 plus root 3. Just have taken the 30 common. So 31 plus value of root 3 is 1.732. Okay? That is equal to 30 into 2.732 and then calculate. 81.96 centimeter is the final answer of AB. So this was about this particular chapter. Okay, I'll come up with one or two more examples so that becomes clear. Next, look at this question. A ladder is placed. This is a that is not exactly the figure is given here. It is a question type. Okay, so here you have to write statements obviously. Okay, so let's read the question first. A ladder is placed against a vertical tower. If the ladder makes an angle of 30 degrees with the ground and reaches up to a height of 15 meters of the tower, find the length of the ladder. Okay, so it is a question that is provided to you. You have to first draw the diagram. Okay, so to make the concept clear. So the first thing is that I have done is, the first thing that is said here, a ladder is placed against a vertical tower. if the ladder makes an angle of 30 degree that 30 degree with the ground, that means it is making a 30 degree angle. So I have drawn this AB as a tower, and this is lying, AC is the ladder which is lying on the tower, that is the tower, and it is making an angle of 30 degree with the ground. So the ground is BC. Okay, so you can have a clear picture that this is the ground, this is the ladder, and this is the tower. Okay, now it has been set and reaches up to a height of 15 meter of the tower. So that means wherever it is touching, this tower here, that is AB, is 15 meter. Okay, from the ground at 15 meters height, the ladder is touching the tower. So this is a particular diagram of this question. Next, that we have to see that the question given is that find the length of the ladder. That means we have to find AC, right? So two things are given to us. One is the acute angle that is given, and the second is the length of the tower is given to us. We need to find the length of the ladder. Now, for finding out the length of the ladder, I have said already that we are using tan in most of the cases. But here you can see, here this is the hypotenuse, this is a perpendicular. So which particular ratio has this perpendicular and hypotenuse? That is sine. That is why I have used the value of sine here. Sine 30. Because we know it is perpendicular by hypotenuse. That means AB by AC. So that means 15 by AC. So now in this case, sine 30 is half. That is equal to 15 by AC. Now AC is equal to cross multiply and get 15 into 2, that is 30 meters. So the length of the ladder that we got is 30 meters. I hope it's very clear. The first thing that you need to do is that whenever you have this type of questions, first draw the diagram. Accordingly the question is given, and then solve it. Okay. Now we have come up with a question same type. See, let's read the question. The perimeter of a rhombus is 96 centimeter and obtuse angle of it is 120 degree. Find the length of a diagonal. Okay. Both the diagonals you have to find. Now diagonals of a rhombus are not equal, but wherever they bisect each other, from there, okay, you can say OA is equal to OC. Again for the other diagonal, OD is equal to OB. Okay, and each of the diagonals bisect the angles equally. Okay, bisects the angle. That means OA is bisecting angle A. Okay, and OC is also bisecting angle C. Again similarly, OD is bisecting the vertex D, and OB is bisecting the angle B or the vertex B. And as you know that all the sides of a rhombus are equal, and one more point, that the angles of the vertex are not same, but where they bisect they form, where the diagonals meet they form 90 degree. Okay, that means AOB equal to BOC equal to COD equal to DOA, all are 90 degree angles. Okay, so we can consider each of these sectors as one right angle triangle. Okay, now let's come to the point that perimeter is given as 96 centimeter. So we know 4 side means 4A equal to 96. So each of the side we are getting as 24 centimeter. That means AB, BC, CD and DA all are the measurement having 24 centimeter. Next, we know that the diagonals bisect the vertices. That is, OA is bisecting the vertex A. That means we can say DAO equal to angle OAB, right, which was given 120 degree in total. So whenever it is bisecting, that means this angle will be 60 degree and this angle will be 60 degree. I am writing it here so that you can understand. This will be 60 degree as well as this also will be 60 degree. Okay. Next, cos 60 we are considering. Why? Because first we are considering this particular triangle. In triangle AOB. Okay, we are considering the triangle AOB. Now in triangle AOB, which two angles are adjacent to each other that will be taken as base? That is OA, because the acute angle is 60 degree and here is the 90 degree right angle. So this particular OA will be taken as the base, and we know the side AB's length, right? So we have the base, we have the hypotenuse. So base and hypotenuse, in which ratio are we getting? Obviously the cos. You can take sec also, okay, that is up to you. So I have taken cos 60, that is base by hypotenuse, that is OA by AB, that is equal to OA by 24. Now cos 60 is half, equal to OA by 24. So OA is equal to 24 by 2, that is 12 centimeter. Okay. Now in the rhombus we know, already we have spoken about wherever it bisects, the diagonals bisect, there for each of the diagonals OA is equal to OC. So the length of the diagonal AC is OA plus OC, that is 12 plus 12, that is 24 centimeter. This was the first, for the only the first diagonal. Here it has been mentioned diagonals, that means we have to find BD also. I was not having enough space here, so this is the first case where I have shown AC is equal to 24 centimeter. I hope this is very clear to you. Next, again in the second case, we are going to come up with BD. Till here I think it should be very clear. You can rewind and see it. Next, the second case. In triangle AOD. Now next triangle that we are going to consider is AOD. Why not other triangles that I am considering? Because we knew that this angle DAB was given 120 degree. And since OA was bisecting this angle A, so we have both the angles as 60 degree and 60 degree. So we can obviously consider these two triangles for getting a quite easy step. Next, so we have already completed the calculating the first part, that is for the diagonal AC. The second part which we are going to do here is finding out the value of BD. Now for that I have considered AOD, the triangle AOD. Now for AOD, you can see we already have this 24 centimeter, right? We need to find out this OD, right? And we have already got from the other, that is in the first case, AO is equal to 12 centimeter. OC is also equal to 12 centimeter. So considering this particular triangle, this is the base, this 12, AO is the base, since here the acute angle and the right angle is there, and this OD is the perpendicular. So the perpendicular and the base, again we are coming back to tan. So tan 60 is equal to perpendicular by base, that is OD by OA, right? So OD by AO is given 12, we have got from the previous steps. So root 3, tan 60 is root 3 is equal to OD by 12. So OD is equal to 12 root 3, 12 into root 3. So 12 into 1.732, the value of root 3. So we are getting 20.784, okay, centimeter. Now we have already discussed that wherever it bisects, the diagonals bisect, those two becomes equal, that is OD is equal to OB. So BD, the whole diagonal, is OB plus OD. So here we get 20 plus 0.784 plus 20.784, we get 41.568 centimeter. So this is the workout of this particular sum. Yes, it's a bit long, but yes, I think it's very easy. Okay, once you know the ratios, it's very easy to solve out these sums. And the best thing in these type of sums is, first draw the diagram to make it clear. Okay, and obviously you have to know the properties of this particular quadrilateral also, that is the rhombus. Okay, that is also important. So this was all about this particular chapter, solution of right triangles. Next we'll be coming up with another chapter of trigonometry of class 9 obviously. So stay connected with us, and if you have not seen, I said please press the I button over there. You will be getting all the other videos of trigonometry that we have previously done. If you have liked this video, please like, share and subscribe. And please don't forget to press the bell icon, because you will be getting the other videos also, the notifications. Thank you. Have a good day.